Hey everyone, this is Student Notes 10.6, Surface Area and Volume of Spheres. The sphere is the last three-dimensional figure that we are going to be talking about in Unit 10. And we're going to start by talking about a few of the sphere's qualities right here. A sphere is a set of all points in a space equidistant from a fixed point called the center. Obviously, the very middle point in this sphere, equidistant from all the edges, is called a center. The second blank, a blank is a segment that has one endpoint at the center and the other endpoint on the sphere. So that's actually the picture right here. One endpoint in the center, the other endpoint on the end of the sphere. So that would be a radius. And a blank is a segment passing through the center with endpoints on the sphere. So each end passes through the center and touches the other end. That would be a diameter. These things you are all familiar with. The cross section of a sphere is a blank. Remember that a cross section is when you literally slice something open. So if we were to slice open the sphere, you actually see the cross section here. We slice off the bottom. If you turn the sphere over and looked at it, it would just be a circle. So the cross section of a sphere is just a circle when you slice it open. And there is a main circle or cross section when you cut through the middle. If the center of the cross section is also the center of the sphere, then it is called a great circle, is the name of it. It's the biggest circle you can make, and it slices right through the center of the sphere. It's called a great circle. Okay. Let's talk about the two formulas that you need to know for sphere. Today we're doing both surface area and volume. We haven't done either one yet. Both of these formulas are on your formula chart. The surface area of a sphere, there is no lateral surface area of a sphere. There's only total surface area of a sphere. And so there's only one formula. And the formula for surface area is 4 pi r squared. Surface area of a sphere is 4 pi r squared. The volume of a sphere is 4/3 pi times radius cubed. 4/3 times radius cubed. Okay, let's go ahead and use these two formulas in the next few problems. We are going to start with problem number 2. Find the surface area of each ball given the diameter. Leave each answer in terms of pi. So we have a tennis ball here on number 2, if you couldn't tell. And it tells us the diameter of this tennis ball is 68 millimeters. But when we are using surface area, our surface area formula is 4 pi radius squared. Notice that we need the radius and not the diameter. So if our diameter is 68, and if we were to cut this in half, half of 68 would be 34. Okay, so let's go ahead and take, oops, obviously I made an error right there. I wrote diameter instead of radius. Let me erase that really fast. Okay, so our radius is 34, so let's go ahead and plug that in to our surface area formula. 4 times pi times 34 squared. Okay, so we're going to need our calculators definitely for today because we've got some weird numbers, some big numbers. So 34 squared is 1,156. So 4 times pi times 1,156. If we want to leave it in terms of pi, so we're just going to put our numbers in the calculator, not the pi. So 4 times 1,156 is 4,624. Pi, because we're in terms of pi, millimeters squared. Okay, it's squared because we're doing surface area on this problem. Okay. Let's go ahead and look at example number 3. This involves a sliced open grapefruit, and you can see that this is the great circle as it's sliced open, and here's the center. A grapefruit is cut in half to create a solid resembling a hemisphere. Okay, this word is important because a hemisphere, kind of like the northern and southern hemispheres of the Earth, a hemisphere is just half a sphere. Oh my gosh, can't spell. There we go. Half of a sphere. Um, Find the total surface area and volume of this grapefruit. Okay, so remember that we are finding a half a sphere, so not a whole sphere. So we're using these two formulas, but we're using only basically half of the formulas because we only need half of the surface area and half of the volume. So instead of surface area being 4 pi r squared, it's going to be 2 pi r squared because we're only using it for half the sphere. And for the volume formula, instead of 4/3 pi r cubed, half of 4/3 is just 2/3 pi r cubed. Okay, so these are the two formulas we'll be using because we're only using half the sphere. Okay, so if the diameter is 12, obviously our radius would be 6. Okay, so that's what we need to plug into our formulas. Surface area is equal to 2 times pi times 6 squared. Okay, remember, again, we're using the 2 instead of the 4 because we're using half the sphere. Okay, so 2 times pi times 6 squared is 36. And then we're still leaving in terms of pi. So 2 times 36 is 72 pi, and it's in centimeters squared. Okay, so that's our surface area of just the hemisphere. And we're actually just counting like the the uh, the the peel of the grapefruit. We're not counting the actual the grapefruit part up here. We're just counting around the peel, okay, for the surface area. For volume, let's go ahead and plug in 2/3 times pi times our radius is 6, and we got to cube it. Oops. Cube it. Okay, so when we go to our calculators, you can either do 6 times 6 times 6, or you can do 6 to the power of 3. So here's the power of button 3. And you get 216. So we have 2/3 pi times 216. So in your calculators, you're just going to do 2 divided by 3 times 216. And you get 144. So our volume of our half of a sphere or hemisphere is 144 pi centimeters cubed. Because we are doing volume, everything is cubed. Okay, let's turn the page over. We're going to look at example number 4. The surface area of a sphere is 100 pi meters squared. Find the radius of the sphere. So in this case, we're actually going to be working backwards because it gives us the surface area. And remember, our surface area formula for a sphere, not a hemisphere, but a whole sphere, is 4 pi radius squared. Okay? But we know what the surface area is. It's 100 pi. So we're going to plug that in for the surface area. So 100 pi is equal to 4 pi radius squared. And we're looking for the radius, so we have to work backwards. We have to divide to get the r squared by itself. Okay, we need to divide by 4 pi to both sides. It's nice when you divide by pi because usually the pi's just cancel out. And the 4's cancel there. So 100 divided by 4 is all we have left, which is 25. So 25 is equal to r squared. And of course, to undo a square, you square root it. So the square root of r squared is r. Oops. And the square root of 25 is 5. So the radius of this sphere is 5 meters. Okay, let's move on. We're going to save example 5 for class. Let's move on to number 6. The volume of a sphere with a diameter of 18, I'm sorry, find the volume of a sphere with a diameter of 18 inches, okay? So we're talking about volume in this case, which is 4/3 pi radius cubed. That's our volume formula for a sphere. We know the diameter is 18 inches. So if the diameter is 18, then our radius is half of that, which is 9. So all we need to do is plug in to our formula. 4/3 pi times 9 cubed. Okay, we got to go to our calculators. 9 cubed, or 9 times 9 times 9, is 729. So we have volume is equal to 4/3 pi times 729. We're going to leave it in terms of pi. So we're just going to take 4/3 times 729 in our calculator. 4 divided by 3 times 729 in our calculator. We have 972. So the volume of this sphere is 972 pi and inches cubed. That's what we're measuring in. Okay, let's look at example number 7. Find the volume in terms of pi of a sphere with the given surface area. Okay, so this one's a little bit different because yes, we're finding the volume, kind of like number 6, but instead of giving us the diameter or the radius, it's giving us the surface area. So the first thing we have to do is work backwards using the surface area. So 16 pi right here is our surface area. So, let me change colors. We know that surface area of a sphere, this is kind of like example number 4, is 4 pi radius squared. And it's giving us the surface area. So we need to plug this in for our surface area. So 16 pi is equal to 4 pi radius squared. So we need to work backwards, just like example number 4, to find what the radius is. So we're going to divide, again, by 4 pi to each side. The pi's cancel on both sides, the 4's cancel on the right, and then we have 16 divided by 4 on the left, which is 4, and that's equal to r squared. Well, that's easy, because if r squared is 4, then the square root of 4, our radius is 2. Okay, but we're not done yet because it's asking us to find the volume. Let me change colors. And we know that the volume of a sphere is 4/3 pi radius cubed. Okay, so all we're going to do now is plug in our 2. So 4/3 times pi times 2 cubed, okay? Well, 2 cubed is just 2 times 2 times 2, which is 8. So we have 4/3 pi times 8. Okay, well, let's try that on our calculator. 4 divided by 3, 4/3 times 8. It's going to give us a repeating decimal, so we're going to go ahead and change that back into a fraction by just pressing math, enter, enter. 32/3. Let's do that again. 4 divided by 3 times 8 will give you your repeating decimal. And then you press math, enter, enter, and you get 32/3. So our volume of this example is 32/3 pi meters cubed. Okay, number 8 we're going to do in class together. So we're going to go ahead and do number 9 together right now to finish up this lesson. Example 9 says find the radius of the sphere when you have a volume of 36 pi. Okay, so again, we're working backwards on this one, but we're using volume instead of surface area. So our formula for volume is 4/3 pi radius cubed. And we have the volume, so we're going to go ahead and plug that in for our V. 36 pi is equal to 4/3 pi radius cubed. Okay, so the first thing I'm going to do is change the fact that it's a fraction. So it's 4 divided by 3 pi. So I'm going to multiply both sides by 3 to get rid of the divide by 3. Okay, so we're going to see what 3 times 36 is in our calculator. Oops. 3 times 36 is 108. So 108 pi is equal to, now we canceled out this divide by 3 here because we multiplied both sides by 3. So what's left is just 4 from the numerator pi radius cubed. So we want the radius cubed by itself. This looks very similar to the surface area problem because we're just going to go ahead and divide both sides by the 4 pi. Okay, the pi's cancel on both sides and the 4's cancel on the right. So r cubed is equal to 108 divided by 4. Okay, let's see what that is. 108 divided by 4 is 27. Okay, then I'm going to go show you how to do something that is something you've never done before. Instead of having something that's squared and taking the square root of it, taking the square root of both sides, we have something that's cubed. And so we're going to do something called a cube root, which kind of looks like a square root, but you put a little 3 right here, kind of where it makes a little check mark. So what you're saying is we're taking the cubic root of 27. The cubic root of r cubed is just r. We're undoing a cube. Instead of undoing a square, you square root it. We're undoing a cube, so we're cube rooting it. Okay, and I'm going to show you how to do this in your calculator. Let's go to our calculator. Okay, so before you would just take second and x squared, and that would give you the square root. But you can't do that here, so I'm going to delete that. I'm going to show you where the cube root is in your calculator. It's under math again. Go to math. And before we were just pressing enter for fraction, but if you look down here at number 4, that's actually a cube root because this is the square root right here and there's the 3 for the cube. So the cube root of 27, press enter, is 3. So what this is saying is the cube root of 27, it's saying that if we were to cube 3, it would be 27, which we checked and it is. So it's saying what times itself 3 times would equal 27, and the answer is 3. So our radius from this problem is 3 centimeters. All right, and we will finish the rest of this in class tomorrow.